There's a lot of different ways to render your web apps. It used to just be you'd send HTML to the user, then it was you sent JS to the user and let them do everything. And now we're in this crazy era where everything's kind of mangled together. There are benefits, there are negatives, there's a lot to understand, and I just spent way too much time diagramming it all out. This is some of the most intense time I've spent trying to explain all of these parts. I think this is one of my best videos, so I hope you stick through with it. It didn't start as me trying to explain all of these things. It started with this awesome article from Ryan Carniato about how JavaScript frameworks are changing in 2025. Keep an eye out for that because it's going to come out soon after this. Sorry if the editing and orchestration of this one feels a bit weird. The realization we had halfway through is this video was too good by itself to be part of that. So yeah, if you want to better understand all the different types of rendering, how they work, and how these affect frameworks like Astro, Next, Nux, Svelte, Solid, and everything else, this is one of those rare videos where you're actually going to learn a lot about how the different web technologies fundamentally work. I'm real proud of this one. Stick through the end if you can, if you want to hear and understand what these four things are. But first, a quick word from today's sponsor. Today's sponsor is Clerk, and they make more than nice shirts. They make the best auth platform, and this is coming from someone who was super skeptical. I really didn't think an auth platform was something I wanted because it's not too hard to roll your own auth, right? Kind of. As soon as you have to maintain it, it falls apart. Once you start building components for it, it gets annoying at best. Complying with Google's weird rules about the logo color matching and the size being right, and dealing with policy changes from any of these companies, managing your refresh tokens that vary per platform. There's so much. And I've been to hell and back managing auth on the platforms that I did it myself on. I tried Clerk because I needed auth for React Native, and I fell in love really fast. Now it is the auth platform we use for every single product that we build. If I shipped it in the last 3 years and it has a sign-in button, it's powered by Clerk. And I never thought I would be here saying that. And I'm far from the only one saying this. We got everyone from Guillermo, the CEO of Vercel, CEO of BaseHub in here. This weird Theo guy, I don't know what he does or how he snuck in. Paul Copplestone from Supabase even. Crazy because they have auth built in too, but he even thinks Clerk is worth using, especially once you need to set up stuff like SSO, MFA, and all the other weird regulatory crap. They handle it for you. They also handle the components, and they are stunning. It is literally just the sign-in component or the user profile component. You just mount those and they look great by default with exactly enough customization. It's so good that it inspired us heavily with how we ended up building Upload Thing. We provided components with Upload Thing because we were so impressed with the ones that we got from Clerk. If you're setting up auth on your application, you should give Clerk a shot. Your first 10,000 active users are free, and if they churn in the first day, they don't count. It's so generous. I've been super happy with our experience. I bet you will be as well. Thank you to Clerk for sponsoring today's video. Check them out today at soydev.link/Clerk. So what are these two pieces here? SPA-influenced isomorphic and MPA-influenced split execution. I think understanding this will help you a lot with getting where frameworks are and where they're going. To understand this first, we have to go further in each direction. I'll have full SPA on the left here. It will have classic MPA on the right here. Classic MPA uses a circle, as we all know. The user goes to a server. It's probably gonna be better if I draw lines vertically like this for like what goes where. So you have the user, and we have the server. So the user goes to the web page. We'll say they go to example.com. User goes to the server. The server has to send something back. What it sends back is a key distinction to understand here. In the classic traditional MPA, the server sends full HTML for page. And now if the user wants to do something else, like say they want to go to a different page here, they want to go to example.com/about. Now the server responds with the full HTML for /about. And it's called an MPA, a multi-page app, because when the user navigates and they click a link, they go somewhere, it hits the server, says, hey, this is what I want, and the server responds with it. It doesn't literally mean that the server has a file for each of these, like it has an index.html, it has an about.html, but it could. You could almost think of this like, I go to the server, it sees that I just have a slash at the end here, it knows that needs the index, so it goes and it grabs this file, this index.html file, and it sends that back down for the user. And when we go to about, it does the same thing. It goes and it finds this about page, and it sends the results back to the user. But what if the site needs to be dynamic? What if I need the HTML to have like my username in it or things like that? Then you would not have these static files. Instead, you would have a function that does something like generate home page. And this function will spit out the HTML that we actually send to the user for that page. And when you go to about, it might generate about page. And this will take in the request dot whatever. It'll take in the request object. Maybe it uses that request object to figure out who the user is so that it can embed the right data in the HTML it generates. The point being, the HTML creation either happens ahead of time on the server where it makes the pages, or on request time where it generates the page based on characteristics of the request. And it has to be one or the other. Maybe your home page is a static index.html, so that can respond immediately, but then other pages need to be generated. The point being, the server needs to have a page or generate a page, and it needs to do the entire page at once. Let's contrast this to classic SPA. One click clarification here before we go further, though. I'm going to draw a line. I'll draw a red line, and this is the user clicks a link. So the diagram is done here effectively. Like, we've stopped until the user does something else. This page will do nothing else until the user clicks something, submits something, does something. No additional traffic happens. The user goes to the server, they get the HTML, they now see the page. That's the whole thing. Classic SPA is a little bit different. With the classic SPA, we have this index.html, but instead of that index.html having everything in it, it's just going to have a very minimal scaffold. Usually it's going to look something like head script source equals /app.js, title example.com. JavaScript is disabled. Please fix. So if you go to a website doing a traditional SPA and you go look at the HTML it's sending, it's going to look something like this. I am currently live streaming on Twitch. And if I go to my stream here, I go to the network tab and I disable JavaScript and I reload the page. This is all we get. This is the entire Twitch site until the JS loads. I can even copy this HTML and show you just how simple it is. So I just went through and deleted a bunch of giant script tags that weren't really necessary. They have this inline one for prefers dark mode. I'll even get rid of that. If you get rid of all the script tags, the entire HTML for Twitch is 70-ish lines of code. This is literally 100% of the HTML Twitch gives you minus the JS. So what's going on? Because I go to Twitch and it doesn't look like this. What happens is those script tags tell the browser to go grab more JavaScript that does the actual work. The page itself has almost nothing on it. It has an incorrect title of Twitch. Even though I'm not on Twitch, I'm on my channel page here, /Theo. The HTML doesn't even have the right tag there, which is hilarious because it means if I tweet the link somewhere, it has to do extra work to figure out what metadata exists. It's just not there. It's hilarious. And I know people are saying you deleted meta tags. I didn't delete many of them. It does have OG title there, but the page title is still Twitch, which is funny to me. You get the point. The actual HTML Twitch gives you is effectively a static file, regardless of which page you go to. So it doesn't matter if we go to twitch.tv or twitch.tv/theprimogen or twitch.tv/Theo. All of these URLs resolve to the same HTML file. That's the key. Every different page that exists on your single page app, that's why it's called a single page app, they're all resolving the same page, the same HTML. So it doesn't send the full HTML, it sends a skeleton HTML. And that skeleton HTML, it might have literally nothing in the body at all. It might have a loading state. It might have a no script tag to tell you what's going on when you don't have JavaScript enabled. But the key is that it has this script tag. So once the response is gotten to the user, we then have to make another request. We have to go get the JavaScript. You know, I'm going to do it inline here. Go get the JS. I like these inline arrows a lot. So we go to Twitch TV/Theo. It returns the static HTML that's basically empty with a JS tag. And now your browser has to go get the JavaScript in order to actually generate the page. So then it sends down JS received. Now the browser has to do some things. It has to process that JavaScript. So the browser has to parse and run the JS. And we're going to have to make these lines longer. And hopefully you're starting to see why single page apps aren't the right tool for a lot of stuff. So the page has to parse and run the JS. It then has to hit api.twitch.tv/get some info. This API then goes and hits some other crazy service Twitch has. This case is going to be the GraphQL Edge. This GraphQL Edge is going to do a lot of other crazy shit. We don't need to go into that because you could do anything like this with any stack. The point being, we go there, we get the JSON response the user wants. This then sends, after some amount of time, sends JSON back. I'll move it up a little so it doesn't look quite as brutal. Yeah. So this then sends JSON back that goes to the user, not as HTML, but as a JSON blob. Now the client, theoretically, finally has the stuff that it needs. So the client then uses the JSON to create the correct HTML. And now finally, page is loaded. You might look at this and be like, oh, Theo, you're exaggerating. It can't be that many steps. I am exaggerating, but the other way. I'm exaggerating the other way because in reality, you're not only doing one API call here. Hell, you're not only fetching one JS file. Chances are you fetch those JS files, it checks what URL you're on, and says, oh, this URL needs more JS. So it goes and fetches even more JavaScript. Then it has all the JS it needs. Then it starts to do the things it has to do, which is go get the data from the APIs. And it's not going to do that once either. It's probably going to make multiple calls. If we again go to Twitch and I re-enable JavaScript, did it re-enable itself? Okay, it re-enabled itself. The key here is we're going to go to the network tab. I'm going to clear it, and we're going to, God, it can't even clear it fast enough. I cleared it. We're reloading. See all the shit that comes in when you load Twitch. Do you understand how insane that is? I'm going to pause the stream. Even with the stream paused, do you see all the stuff coming in? Even if we limit this to just XHR requests, which are things that hit endpoints, these are all the API calls being made. And all of these ones are made before the page has finished showing you things. Literally dozens of requests have to be made before the user can see things. And that's just how a lot of the web works right now. And people don't seem to understand that's the React bad that needs to be understood. And it's not because React as a framework is fundamentally flawed. It's because when you have the ability to do everything on client, you start to. But this sucks for so many reasons. So many reasons. And hopefully you can see here that it takes this many steps before we can even do a navigation. So here we'll have user clicks a link. And admittedly, this is where single page apps start to be a little bit better. Because when the user clicks a link, we don't have to go anywhere to start showing something else. Start showing new UI. I almost wish I had put another line here for the browser. Because when the user clicks a link, as long as the JS is already loaded for that new page, you instantaneously see something. You have to wait for a server. The important thing that I want to emphasize here that is hard because I'm missing a line. I really should have put a browser line in here to help indicate this. You know what? I'm going to do the annoying thing and do that. We're going to change this to browser. And we're going to make it the new line of user. I'll put this back here. So the user types in twitch.tv/Theo. The user types that. The browser then goes to the server, gets the empty HTML, goes to get the JS, downloads the JS, parses and runs the JS, goes and makes the API calls, gets the JSON back, JSON blob gets rendered. And I guess the thing I would draw differently here is after that, the JSON is used to create the HTML, which results in the page finally being shown to the user. And then the user clicks a link. The thing that is cool is previously, if we were to do the same diagram above, the browser would have to go to the server to get something. And even though I drew these gaps the same, realistically speaking, this one is a lot more so like here, way closer, and the server is way further. So if you don't have to go to the server to do something, it feels better. There's a lot of ways having everything locally benefits you greatly. So when you click a link, the user is sending navigate to /the Primeagen. If this was built with a multi-page app, we would have to wait for the server to find the right HTML or generate it, send it back, and then you will see something. But until that moment, you get the little loading bar at the top of Chrome, like the blue bar that slowly goes across, and you don't actually have any feedback that you clicked something until the server is done. With a single page app, it is different though. Navigate to the Primeagen. The browser is going to instantaneously generate a new page. It's not an actual new page. It's just going to change the HTML because again, we're in a single page app. Nothing has changed. The HTML that the server sent is still the same. So we're going to generate this new page based on the URL. If you're using something like React Router, you'll have a certain URL bound to a certain part of the UI, and this is how. When you change the URL, it knows which components to render. It starts to render those components. You see the new UI, but one of those components needs some data. So after we've generated this, we noticed we need more data. So request new data for /the Primeagen. This is probably going to be like api.twitch. I'll just put the API call. api.twitch.tv/get/the Primeagen. So now we're going to the Twitch server again to get this data. I'll copy paste this part because it'd be exactly the same. Send some JSON back. JSON goes to the browser. And then the browser uses that JSON to generate correct state. So up until then, you would probably show like a loading spinner or something. And then once you get that JSON back, now you have all the fun powers to get the right content to the user. But what's cool here is you get something immediately. The user sees something, and it could possibly be everything. It's possible you have the data that's needed cached. And now when you click and go to that page, everything loads immediately. It's really cool for that, but it's not for everything and it's not for everyone. Again, to compare to classic MPA, I'm going to add that same breakdown here. User goes to a link, example.com, server sends the HTML down. Now the user sees the result. Great, awesome, fun. But then the user clicks a link. The thing to be considerate of is anytime you cross this chasm between browser and server, you're now waiting. So when you go to example.com/about, you now have to wait a while to get everything back. So I send the request, and I get the HTML back, but I don't have any indication that something's going on other than that loading bar at the top in that time. Not great. And if this was for Twitch, for example, like we were on twitch.tv/Theo, and we go to twitch.tv/theprimeagen, after I click the link, I'm still watching Theo's stream for a while, up until I get everything back. It doesn't change the page I'm on until the server is done. And if the server takes a while to do those things, you're screwed. This has a lot of catches, which is where we're going to start getting into these new models. I'll get to those in a bit, but first we need to talk about here. Because the biggest problem, in my opinion, is this top chunk. I would hope we agree. The bottom chunk's actually nice. It's better in a lot of ways than the traditional multi-page app way of doing things. The problem here is the user doesn't see the right content for a while, and it has to do all of this stuff before they actually get the data. This is where we get back to these two key parts that Ryan included in the article, the SPI-influenced isomorphic and the MPA-influenced split execution model. The first solution we had to this single-page app chaos is actually pretty intuitive when you think about it. We'll say SSR to SPA. What we do differently here is instead of going to the page, sending this empty HTML file with a JS tag, and the client does all the work, we do something quite different. We now run React on the server. React server runtime. Why would we ever want to run React on the server? It's actually a pretty simple reason. We don't want empty HTML. We want complete HTML, which now allows us to send that back to the user immediately. What's interesting is in parallel, while the user is getting that HTML, right when they get it, we now also know that it has a JS tag still. And we can go get that JS tag, receive the JS, parse and run the JS. If it required an API call, we can do it. But there's a good chance that your server runtime actually embedded the data in the HTML. If you go to something like Ping, for example, and you look at the HTML, Ping's a video call service that I built to make it easier for live streamers to do collabs. If we hop in here and we look at next_data, here are the properties that Next.js used to render the page on the server, and it embeds them in the HTML so that you don't have to go refetch them once the React code takes over. It does a thing called hydration. What hydration means is we have this JavaScript on the client, but we also already have HTML written. Normally, what React does is it writes all the HTML for you. But if the HTML is already written, how does the React code know which button to trigger the on-click for? It figures that out by rerunning the same React code on the client. And that's the key. The React code runs once here. So I'll label these green. First, React run. So React runs first on the server. It might run at build time, so it only runs once when you deploy. It might run dynamically. So when a user makes a request, we generate new HTML with new embedded data. The HTML embeds the data needed for this run. The JS goes and gets that. And then we have the second React run all the way over here in browser land. So it runs once on the server, either during build or during request, embeds all the HTML that is needed, including that data. And now, once we parse and run the JS, we can just skip this step. We can get rid of all of these things, assuming the server did them anyways. Like realistically speaking, what is actually happening is the server during this React run either goes and hits an external service like your GraphQL Edge, or maybe it just hits your database directly. So the server hits the database, gets the JSON back, or whatever the server is returning, sends that down as HTML to the user with the data embedded. The browser then has to go get the JavaScript that it needs. Once it receives it, it runs the JS. It has access to all the data and everything it needs. And that is hydration. Hydration is when you rerun the same React code so that your React can link up to the right places in the HTML. And now we're done. That's it. So what's the catch? Like, this has to be bad in some way, right? Like, this just sounds too good to be true. There are catches. Catch 1. What happens if I click a button here? If I have a button that has an on click that does an alert, and I click it before the JS has loaded, and before it has parsed and bound to the button, what happens? When I click, it doesn't know what on click is bound, because when you write button on click in React equals like this, the actual HTML doesn't have an on click on it like that. React is handling all of that itself in its virtual DOM. So the button doesn't have the on click function embedded in it in the HTML. It has to attach to it properly. The on click isn't there until this JS is run and it has been parsed by the browser. And that sucks, because if the page loads, you see it, and you click a button immediately, it won't work, because you have to wait for the button to be hydrated by that JavaScript. So that's the biggest catch, is button won't work yet. And then afterwards, once this is loaded, now everything works. This is a really good model, and it solved a lot of problems. But this isn't the only catch. And also, to be clear, there are solutions to this. Most of the time, what they'll do is in this HTML, they'll send a really minimal JS tag that just creates a queue of all the events for when you click buttons. And then once the JS is loaded, we just replay the things that you had done, which works fine. It solves the problem most of the time, depending on who you talk to. If you talk to the quick guys like QWIK, the framework, they think that this hydration thing is the root of all evil and they're trying to destroy it. I think they're overreacting, but whatever. I'm the React bro. Of course, I think everyone's overreacting. There's another catch, though. The amount of data that is being sent. When you build things this way, you have to send a lot of data multiple times. My favorite example for this is, again, on ping. The privacy policy on ping is a great way to showcase another one of the problems with this model. Here I have the HTML for the page, and if I go to the network tab and we load it, hard refreshed, we can look at the response. There we go. Cool. So here's the HTML from that page. And as we can see in here, all of the text for all of that privacy policy is in here. If this was a single page app, it would be empty. You have to load the page, load the JS, fetch the data, or embed it in the JavaScript, and then finally you would see the content. So what's the problem? That seems ideal, right? I'll show you. See this JS file, privacy policy, random name.js? Let's take a random chunk of this. We'll say a particular service. Command F. Look at that. We have this nested child P, children, O, strong, cool. Here is that exact same text. The entirety of the text for this privacy policy is sent down twice. It is sent once as HTML, because we have now sent the correct HTML to the user, but it's sent again as JavaScript, because this is the JavaScript that created that HTML in the first place, and we need to run the same JS on the client and on the server in order for things to behave and for React to know what is where. Because if I had a button in this paragraph for some reason, and that button had an on-click, and we didn't have all the text to render this, to put the button there and put the on-click there, it wouldn't work. But that means that not only are we double sending the data, where we're sending it as HTML, and we're sending the exact same content as JS, it also means that the JS is full of all of this stuff that we don't actually want to have bogging down our JS. I don't care if the privacy policy can be updated or not on the client. It won't be. It doesn't matter. But it sucks that we have to send all this content down twice, and that now it exists in the JS VM and runtime. It's just more data that doesn't need to be there. So that's not fun. It also kills your search engine optimization, because the browser crawlers aren't going to download the JS and run it and generate the page. They just want to look at the HTML and see what's in it. So there's a lot of benefits to the HTML having the content, but if it has a ton of content that doesn't change while you're on the page, you're just loading a bunch of things that don't belong in JS. And that's a tough balance to strike. One last detail about SSR'd single page apps, because I think it's actually really cool. When the user clicks a new link, the client still can do the generate a new page thing. So it will immediately start showing you something if you set it up that way. But it can also go to the server and ask for something. So if we go to twitch.tv/theprimeagen, instead of the server generating a whole new page again like it did here, because like it could just do this again, but it doesn't. Instead, what it does is it just grabs the data part. So the first time you load the page, the React server runtime has to generate the HTML that the user sees. From that point forward, you can just grab this JSON blob for a given page. And since that has all the data and the JavaScript already exists on the client, you have everything you need to render the page correctly now, which means you're getting a lot of the benefits of both parts here. You get the instant new page experience where you see something immediately, and you get the ability to control those loading states and just fetch the JSON you need instead of having to wait to get a whole new HTML page that re-renders everything. One more catch, by the way, is let's say I was on Twitch and I have a video playing and I click a link to the About page. If we have an MPA, then the player no longer exists. But if it's a single page app, now since the browser isn't navigating, it isn't changing pages, I can have the player move down to a little like picture-in-picture like pop-up thing in the corner as I continue to explore the site. It is effectively impossible to do that with a traditional multi-page app. There are some API proposals that'll make it more viable, but having elements that are persistent while the rest of the page changes like that isn't really a thing that the browser does great. It's part of why single page apps are so cool. And you're getting all of those benefits with this model. You get the correct HTML sent to the user. You get better immediate navigations as you explore and do other things. And now you have a way better experience to get the right content to the user where you're just fetching the JSON blob and can show a loading state in the interim. Really cool stuff. Sadly, the way Next works is that it blocks the whole page load and navigation until it has gotten that JSON blob. So if you used Next in the traditional pages directory, so the old router, which was /pages instead of /app, the traditional single page app SSR story with something like OG Next.js doesn't give you a new page as soon as you navigate because it has to wait for the server to generate that data blob, and you're just stuck waiting until that happens. But at the very least, you can have things persistent on the page. So it has benefits and negatives, but you don't get the thing I really wanted, which was the immediate navigation. I wanted a click to show the user something new instantaneously. So what I had to do is take all the data that requires this server trip and not do it before the page loads. So if you go to like the dashboard on Ping, you'll see something interesting. You'll see a loading state. The moment I click, I'll do this. I am clicking now. Instantly, you get a page. You see, that time it loaded way faster because the data was cached. But when I don't have it cached, I just hard refresh and I clicking now, you get that loading state initially. And the reason you get that loading state is because I don't want to have any data block the navigation. I want to click to immediately show you something and then go fetch the data you need from the API. So despite how cool this model is for generating the right HTML initially, it has the catch of if you use it for everything, then every navigation gets slow again. So in some ways, it is the best of traditional single-page apps and the best of multi-page apps, but it's also the worst of both, where you're getting way too much data being sent down to the client and relying on the client way too heavily, like single-page apps do, but you're also blocking navigation the way that multi-page apps do. How the hell do we solve these problems? Finally, after this wonderfully long tangent, we're back to the two key points that Ryan called out in the article. There are single-page app-influenced isomorphic, and then multi-page app-influenced split execution. These are evolutions of the two different strategies. And this isn't an evolution of standard single page app because we went from SPA to full SSR is what I'll call it. Full SSR is what I just showed where we run the exact same React code in both places. Yeah, good, not great. We now have isomorphic SSR. Isomorphic SSR is code that behaves differently on the server versus on the client. It means I can do something like a loading wrapper or a suspense wrapper, and instead of having to wait for the server to send all the HTML, I can show something immediately. Like if I have this page of HTML, has a body, has a nav, has a div ID equals sidebar, it has div ID equals content. Let's say this is our HTML. This is the HTML for /Theo on Twitch. Twitch.tv/Theo. I'll say ID is content. We'll give it even an actual content. It says Theo. Obviously, the HTML for a different page, like the Primogen, is going to be different. The problem is, it's not that different. That's not great. It's not fun. It sucks that we have to wait for the server before the user sees anything when we do this navigation. When I click a link in nav to go to this other page, I'm waiting until the server finishes it. Why div ID and content instead of main? I'm lazy, but whatever. You get the idea. What if we change this up a little bit? So right now this is HTML. Imagine this is JSX. And we put some indicator here that's don't wait for this. We'll say end there. And we do the same thing over here. We wrap this with an indicator of some form that we don't want to wait for that part. Now, it's theoretically possible when you do the navigation, since we know everything else is the same, to leave those parts, do something here, and then go get that extra data. We can go a step further. Well, again, pretend this is JSX. It's a wonderful component called suspense. So if we wrap this part here in a suspense, give it a loading state or a fallback equals loading. Now what will happen is when the client gets the page initially, it can wait and not render this part. Cool, awesome. We hopefully get how suspense works, where if you wrap something in suspense, it no longer blocks render and you can get stuff quicker. Cool. Where this gets way cooler is on navigation. Because if I go to a different page and the only things that have changed are the things that live inside of these boundaries, when I click the link in the nav, we don't immediately get back this with the Primogen. What we get back is going to be the loading thing there. And now, while we wait, we get to see something. We get to see that loading state as soon as we click. And the server is going to get what it needs for us to put the correct content there. Super, super cool. Where it gets even cooler is, what if we don't send JSON down that then has to render the right state? What if we just sent the right HTML down? So let's diagram this one out. Isomorphic SPA. So realistically speaking, top half here can mostly be treated as the same. There are benefits, like if you have a component, like a server component in React now, that only runs on the server, you don't have to send that same JSON like data down as part of the JavaScript anymore. Kind of. It does have to know where elements are and it serializes in a weird way. So it's not fully removing the double data problem, but at the very least, it's not quite as bad and it doesn't live in the JS runtime the same way. It's different. But for the most part, it's fair to say with the isomorphic model, the first page load has not changed much. But the key with isomorphic is that it means it runs differently in the different places. So if we have the same code, some of it runs only on the server, some of it only runs on the client, some of it runs differently between the server and the client. That's where the magic starts. Because when we navigate to the Primogen, when we go to that other page that has the different content, instead of waiting for the server like we did here, we can do two things at once. We can immediately kick back, and instead of showing the new state, we'll immediately show loading state, because the suspense boundary running on the client tells the browser and tells React, hey, when we go to this new page, just show a loading state here while we're waiting for the rest of the data to come through. As long as any data request is under a suspense boundary or a loading indication of some form, we no longer have to wait for the browser to get the data before showing the user something. So we can immediately show them the loading state, while at the same time, the server is going to generate the element that we need to put there instead. So we are now doing the thing we weren't before. I showed before that we wouldn't run the React server runtime on further requests. We would just generate the JSON. No longer the case. Now we're doing this again. Ignore the first React run because no longer the case. We no longer think about the number of times React runs. We kill that too for the same reason. So now we go to this page, server runtime, and generates the new page, sends the new JSON back to the server runtime. And then this now can send the changed HTML. Now the server can send the things that were under those suspense tags to the browser. Browser gets new HTML chunks. And then once the browser has those, it can fill in the loading states. So replace loading states with correct content. I don't know how to explain this other than to say it's fucking awesome. It's so cool that we can have the single page app benefit of clicking something and immediately getting to see the result, as well as the benefit of not having to send JSON and all the different ways to render to the client. Like, let's say theoretically, we had a bunch of different SVGs depending on which person you went to. Like Prime and I have different SVGs and they're both big and there are hundreds of thousands of them. If that was all encoded in the JavaScript on the client, then we have to have a giant JS file for all the possible states the UI could be in. If you have HTML on your page in a traditional React app, the React code to render it has to be in that JS bundle. With isomorphic single page app server component style development, you now have this magical ability to have a ton of JavaScript that renders different states. And instead of sending all the JS down and the JSON down to create that HTML, that giant TypeScript file can just live on the server and only send down the HTML. So instead of sending this giant pile of JS that has every possible state your UI can be in, combined with the JSON that actually has the data you need to do that render, you can just send the HTML. This is also what makes something like HTMX so magical, is it's not sending JSON down to the browser to transform into HTML. It just sends the right HTML. That's really cool. And you're actually starting to get the benefits of all of these solutions here, because you get the immediate navigation of an SPA, you get the HTML first development of an MPA, and you get a developer experience where you don't feel like you're fighting between those two different things. There are catches, though, as there always are. The biggest catch is you can't have that HTML file come from a static CDN anymore. You can't have a static HTML file the same way that we did all the way back up here with a classic SPA, where every page on Twitch resolves to the same index HTML file, which means when you go to Twitch, the latency to download that file, instantaneous. You don't have to wait any amount of time for it, which is really, really cool. So we can't have the static HTML that's cached on a CDN. Now every single request ever, be it a web scraper or a traditional user or anything between the two, all of them have to run server-side JavaScript to generate the page and to generate whatever content needs to be filled in. And it is not easy to set up. There are cool platforms like Vercel, and I'm pretty sure Netlify is starting to do similar stuff, where they'll have an edge that they run in front. So instead of going straight to the React server runtime, you'll have a step in between, like an edge of some form. We'll put in the edge worker, is what I'll call this. The edge worker will check the URL you're trying to go to and see if it has a cached HTML file for it or not. If it does, it'll grab that HTML file and send that. If it doesn't, then it goes and kicks the work back off to that server runtime to do the actual page generation and send that back. There's a whole additional layer here of partial pre-rendering where it gets both a static part to start and the server runtime code to finish up, so you can get something quicker and the rest later. That's going to make this way too long a video. Go check out any of my partial pre-rendering content if you want to better understand that part. The point here is simple, though. When you have a model like this, you no longer get to just send a static HTML file. You now have to have backend code, not just running JavaScript, but running React. You cannot do this model if you're not running your React code on the server that resolves the entire website and every URL. So if Twitch was to move to this model, they wouldn't be able to serve static HTML files and then have every endpoint running via Go code. You'd have to have, at the very least, twitch.tv, the site itself, get resolved by JavaScript. And I understand why a lot of people are hesitant to do that. There's even companies that won't let you do that because the front-end team's the front-end team. They're not allowed to go spin up APIs and do those things. And that's where this fourth very compelling option comes in. MPA-influenced split execution. This model is actually very similar to the isomorphic model we just did. I'm going to grab these parts again. Remember when I said we had this HTML page that had the suspense, and that allowed for React to know where to put the loading spinners and what to wait for and not wait for? The way that isomorphic MPAs work is a little bit different. Instead of resolving via one request and sending down the dynamic data when it's ready, or just blocking until the whole thing is done, this element is an island. And this island has some indication of what it needs to do. We'll just pretend it has a URL in it. We'll say island source equals /content/Theo. So what the hell does this do? What this does, first and foremost, is it lets you host this in a static CDN. You can take this file and throw it in S3, and you're good to go. That is really, really cool. So now we get to host this the way we're actually used to with both single-page apps and traditional static multi-page apps, where we have a bunch of HTML files just sitting on a static thing like S3, just some CDN that when you go to a URL, gives you HTML immediately. What does this island thing do then? This is where the pattern we're talking about gets really cool. Chances are this isn't going to source to the same place. It's probably going to source to like api.example.com or astro.example.com or something like that. It's to indicate this isn't the static CDN that just sends HTML. This guy is going to make a network request to get the new HTML it needs. So the page can load statically without using a real server. It can be cached. It can do all the things you would expect from traditional HTML, where you can just go to the page and it loads. Any parts that are dynamic. So if this island isn't the content for Theo, it's my shopping cart. All the page around my shopping cart might be the same for every user, but that shopping cart part is personal. It's for me. And I shouldn't have to wait for the whole server to render the whole page before I can see something. So if we have static pieces and the individual parts are indicated of this is dynamic, go get some JS for this, and then go get the actual data for it, we've kind of inverted the model where we have these islands. And this is where the term comes from. It's islands that are dynamic and interactive. The rest is all static. Every user going to, in this case, twitch.tv/Theo, let's change this to like amazon.com/cart. Up until this island, every single user sees the exact same page. The only part that's different is the part in this island. And when you use something like Astro for this server-side island creation, what it does is once the page is loaded, it runs a tiny, tiny bit of JS that will go to this URL. It will use your cookies and all of that on the server side to generate the right content to then embed into this part. So let's diagram it. So the user goes to amazon.com/cart. Amazon has this pre-generated cart.html file sitting on the server waiting for you to go to it, so it loads effectively immediately. This isn't complete HTML, it's mostly complete HTML. Gets sent to the user. And as soon as this loads, there's a tiny bit of JS that has to run. So I'm going to indicate that. It almost feels unfair because it's so little, but I am going to indicate it here. Run embedded JavaScript. And this embedded JS goes through the page, looks for any islands, and it will find the island that we had drawn here with whatever the source is to get the shopping cart content. So here it will now go to the server again and say, hey, I need /content/shopping cart because I need the HTML to put into this empty piece that isn't ready yet. In this time, user sees renders everything but the islands. So the user sees everything but the island, and then we go run this embedded JS. It hits this endpoint with the shopping cart data in it. It does all the fun things we had done up here. I'll just grab this. It can run the React server runtime if you want, because something like Astro supports whatever framework you want it to. But realistically speaking, chances are when you do a server island like this, you're just going to do it through Astro. So I'll say Astro server runtime. Now the Astro server runtime will hit the database, get some JSON back, and then here, island HTML content. Here we are. The Astro server now creates that remaining HTML content, which can be sent pretty much directly down. No JS back and forth, none of that. We just send the content to the browser, remaining HTML, and then the browser uses that tiny bit of JS to figure out where it goes, put it in the island. We're done. So what's really cool about this solution is you don't have to do some weird shit to get the static CDN benefit for that first load. One of the most painful things I accepted when I moved to the server component model, when I moved from ping being traditional SPA for the most part, over to upload thing, which was very much the new server render first methods, is that the HTML had to either be fully static with no dynamic behavior at all, or it had to be fully dynamic, which means you're waiting for the server before the user sees a single thing. I hated both of those compromises. And what I found myself doing was just generating a static, mostly done HTML file with a giant loading spinner, and then do everything on the client from there. And that's why ping still feels really fast. Like once the ping page is loaded, navigating flies. It feels even faster than stuff I've built like upload thing. But upload thing uses way less resources and sends way less stuff back and forth because it is using the new paradigms. There are a couple benefits that I am aiming for when I build. Benefit 1, users clicking links should change the page instantly. I don't want a user to ever click something and not be sure if stuff is changing or not. I also want to be able to do things on the client, like have a pop-up video player that doesn't go away when you're moving from one place to another. I also don't want to wait for a server for first page load. If the server has to generate the page before the user can see it, there's an inherent penalty every time you navigate, especially when you first open the page, especially if you're using serverless and you're hitting a cold start. It can take seconds before you even start getting a response from the server because it has to spin up, connect to your database, and start generating stuff just to realize that it's sending you a static asset anyways. It sucks. So I don't want to have to wait for the server to generate a full page before the user sees anything. The third thing I really want is I want dynamic parts to be generated on server. Parts generated on server. I don't want to have to wait for the page to load HTML, load and parse JavaScript, run the JS, go hit a server, render a component once it gets the data back, realize it needs to go fetch 5 more, and that back and forth, the thing I spent the whole first third of this talking about with the traditional SPA all the way up here. I want to avoid all of that, blocking the user seeing the real content. And these 3 things don't play together nice. Because if you're generating a response on the server, that response has to come from the server, which means if the page came from a CDN that is static, but it has dynamic parts on it, you're now inherently blocking the whole page on that dynamic part of the server. So it almost feels like inherently that when we do the dynamic part generate on the server, that we're hurting our goal here, where you can't click a link or go to a link and immediately see the content because the server has to generate the whole thing, even if most of it is static. I hinted at partial pre-rendering earlier, and this is why I think it's really cool. It lets you have the static parts respond pretty much instantaneously, and the dynamic parts get generated dynamically on the server on request time. It's kind of the best of both, but it comes with a catch, and the catch I detailed earlier. Where did I put that diagram? Here. You need an edge worker that can go grab the static part out of a CDN for you, so you don't have to wait for something to generate it. You don't have to wait for your server to generate that first part. You can grab the initial HTML out of the CDN, send that back immediately, and then stream the rest down when it's ready. That is a really cool thing, but it requires you to have very smart infrastructure that has this edge worker that does the initial resolution to pull from a CDN. And this would require your front-end devs to be experts in all things infra, or go pay Vercel and move their backend there, which you know how the backend teams are going to feel about that. These features, they're not exclusive in the sense that Vercel has locked them down and won't let anyone else do it. They're exclusive in the sense that Vercel's one of the few places that has built it. But that is what makes the MPA solution here, the split execution server island model, so cool, is you don't need to have that resolution layer. You can think of this like, where does the static HTML get the dynamic parts added to it? With the new Next.js Vercel model, the static part and the dynamic part, the difference is identified on that edge worker. The static comes through the CDN and goes back to the user. The dynamic gets forwarded onto the server and goes back. The effective only difference here is instead of that edge worker being a thing that is run on Vercel, there is no edge worker anymore. Now it is run on your device. The difference here is previously where we had the edge worker, we now have this little bit of embedded JavaScript. It is doing the exact same thing. We get that static CDN HTML from the server, then this JavaScript identifies the dynamic parts and then kicks that off to the server to generate. And instead of that like box running behind doing that work, now your client is instead. The cost here is that you don't get to kick both off at the same time. So if you go to /cart in the other model, the user starts getting the HTML and the server starts generating the rest at the same time because they're both being hit by the same thing. Here we have to wait for the user to get stuff before it kicks off the next part. The benefit is your infrastructure that handles this is significantly less complex and can be hosted in all the old traditional ways you're used to, where this part's just S3 and this part is just a dumb node server or Lambda. If you do it the other way, your infrastructure has to be more complex. So there's benefits and negatives to all of these strategies, and it's really cool to see us moving as an industry towards a place where you can have dynamic parts that are server rendered, static parts that are instantaneous, first page loads that feel great, and navigation that feels like the code is running on your machine. That is the win I want to see. I want all of these parts to come together in a way where the tools we use just kind of work right, and we don't have to think about the dynamic versus static parts anymore. The problem we have right now is that other than Cloudflare, most re-provisioned edge services like Netlify and Vercel have to route traffic through their main service before back to the edge, making the edge slower. Yep, absolutely. There are a lot of catches to all of these models, but there's a lot of benefits too. As I mentioned at the beginning, this video was kicked off by this article by Ryan Carniato, JavaScript Frameworks heading into 2025. This video is going to be a fast follow, so if you haven't subbed already, please do. All of this comes together in the end. Really excited for it. Thanks again to Ryan for writing this, and thanks to you for sticking through the chaos that was getting through all this. Seriously though, go watch that JavaScript Frameworks in 2025 video. It's going to be a banger. Anyways, peace nerds.